what is the equation you're trying to solve? At every lattice site, there is something going on. There is a potential. And what happens dynamically, for example, you used to be phi, but now you're phi cube in the next step of in dynamics. So there is something, going locally. And potential is local. So also when you take continuum, potential is a function of Q, V of Q, where Q is a spatial coordinate. Now, in usual mechanics, there's also this momentum P, which looks local to you because, but when you discretize it, you realize it's not a local, it's just comparison to the neighbors. So, the derivatives in continuum, which seem to be defined at a point, actually just a limit of procedure of comparing yourself to the neighbors. So first derivative, you have to compare yourself to one neighbor. Second derivative to two neighbors. Third derivative to three neighbors in one dimension. Now, if you have more dimensions, then you have to compare yourself to those neighbors as well. So that's what kinetic term really is. It's a comparison of who am I to who is around me. And the law, which is Euler-Lagrange law, but derivative of potential, the law is this recurrence relation. It says, I'm some size, but I have to compare myself to my two neighbors in temporal case, or my four neighbors in spatial temporal case. And the difference between me and them, there's a minus sign. The difference is the one that's mandated by the, Soviet Presidium Committee, which says it should be 7 or whatever. That's called symbolic dynamics or whatever, forcing term. So you have this condition. And what's nice about this condition, it doesn't care whether you're in one or two dimensions. It's just neighbors. Now, when you're in higher dimension, you have more neighbors. It's the same method. So there's nothing else to it. So, you see, well, I'm sticking out by 1 foot. That's not allowed. So what do? I get cut down by size by looking, using this equation. My neighbors tell me how tall I should be. So that's what inverse iteration is. It says, look at my neighbors. They all get together. They say he should be 6'2". And, in detail, they're comparing, phi cube, but I'm phi, so I have to take a cube root. And, if I have coupling constant, I have to divide it by coupling constant. It's a formula, so there's nothing to do. And that's it. There's nothing to it. So now, you have to do it for everybody. So you have to go through space-time loop, which you know how to do. Space-time loop is same as time loop. And on a rectangle, it's easy to do. If you're in some slanted tile on the space-time, then you have to use these boundary conditions. So it's really, really not a big deal. And we are so lucky that it's a kind of trivial calculation.